Assalamu alaikum students. Our today's lesson is about atomic structure. You had already learned many things about the structure of atom and about atoms in your previous classes. Let's start with the atom, like what atom is. I hope you are well aware that what atom is. An atom is a smallest particle of a chemical element that can exist independently. So this is an atom, but atom also has some smaller particles that are known as subatomic particles of an atom. Subatomic particles mean atom is further divided into these smaller particles. Those are called subatomic particles. Those subatomic particles can be memorized by the term pen. P stands for protons, E stands for electrons, and N stands for neutrons. So, protons, electrons, and neutrons are subatomic particles of an atom. If we are looking at a rough structure of an atom, so this is an atom, and that middle part is a nucleus. So, talking about the nucleus contains two particles in it. Those are protons and neutrons. Protons and neutrons are present in nucleus. Because they are present in nucleus, they also termed as nucleons. And this is shell or orbital or energy level. And electrons are revolving in it, means electrons are present in electron shells. In this way, we can get the information about the subatomic particles, that where exactly the location of subatomic particle is in the atom. Now we have to learn about the relative masses and charges of those subatomic particles, that we can write in the form of the table that information. These are our particles, means subatomic particles. Subatomic particles, symbol by which they can be denoted, their relative masses, and finally the charge on them. Firstly, we are writing for the proton. Proton is denoted by a small alphabet P, and its relative mass is 1 and charge on it is positive 1. Next, we have electron. Electron is denoted by E, relative mass is 1 over 1840 of the mass of proton or neutron, and charge on it is negative 1. Lastly, we have a neutron, and neutron is denoted by n. Its mass is 1 and charge on it is 0. What is meant by 0? 0 means that it has no charge on it, or it bears no charge means it is neutral particle. It don't have any electrical charge on it. So over here we can write neutron is electrically neutral particle. Neutral particle means it is not attracted towards positive or negative particles. One more thing that we have to explain further, and it is the mass of electron. So mass of electron is such a small value that it is negligible. It is negligible. It is negligible means it is not included in the mass of an atom. So from here we can get a statement like all the mass of atom is present in nucleus. All the mass of atom is present in nucleus, as nucleus contain the two particles, protons and neutrons. And protons are positively charged, we have already seen, but the neutrons don't have any charge on it. It means that nucleus is positively charged. Nucleus is positively charged. Nucleus, we have a positively charged particle. Now next we will see, like if we have a source of particle, this is a source of particle, source of particles. In this source of particle, a beam of particle is originating. This is beam of particles, a ray of particles we can say, and this beam of particle is passing through or passing between the two charged plates. Two electrically charged plates, one carry the positive charge and other bears the negative charge. So when the beam of particle is passing between these two plates, some of the particles are passing straight away, means that they remain undeflected. They don't have any action of charged plates on them. Undeflected particles. So these undeflected particles are neutral. If they are neutral, it means that they are not affected by the positive or even the negative charge. If they are neutral, so they can be the neutrons. Some of the particles are deflected towards, or they are attracted towards positively charged plates. So positive attracted the negative. So these are negatively charged particles, and negatively charged particles are electrons, and some of the particles will attracted towards the negative plate. Those that will be attracted towards negative plate, these are the positively charged particles. Positively charged particles, and those positively charged particles are protons. So here is the description about the particles and their charges when they are passing through the electrically charged plates. Now we are considering the symbols for the atoms. For example, we are considering carbon. Carbon is 6 into 12. So this letter is representing the symbol of element, symbol of its element. The smaller number, this is smaller value, this is known as atomic number of an element. Atomic number of an element. And the greater value. We have two values upon the symbol of an element. One represent the atomic number and other represent its atomic mass. This is its atomic mass. Now we will discuss these two terms in detail. So what atomic number is, we are going to explain for atomic number. Atomic number. Basically, atomic number, it represents, it is also known as proton number of an atom. It is also represent the proton number of an atom and denoted by a letter Z. Atomic number is denoted by a letter Z. Now atomic number also representing the number of protons, means the value 6 is also representing its number of protons. The number of protons present in an atom are represented by this number. All the elements, if you can see the periodic table, means we have the other elements as well: oxygen, nitrogen, chlorine, fluorine, bromine. We have the metals: sodium, potassium, calcium, magnesium, zinc, copper. So these elements have their distinctive atomic number. Atoms of different elements have their distinctive proton number. Means if atoms have proton number 6. So all those atoms are of carbon. If the atoms of element have proton number 11, so all of these elements all of these atoms are of sodium element. From here we can get the information that each atom of element has its specific atomic number that the other atom don't bear. So another information that we can get from here is all the atoms of elements have same number of protons and electrons in them. This statement explains the fact that atom is electrically neutral particle. Atom is electrically neutral particle. Why an atom is electrically neutral particle? Because it has same number of protons and electrons. So what happen if they have the same number of protons and electrons? We had already learned that protons bears the positive charge while the electrons bears the negative charge. If both have the same number of protons and electrons, so the positive charge balances the negative charge. Positive charge balances or cancel out the negative charge. When the positive and negative charge will be cancelled out, it means that atom don't have the charge on it. So in this way we can say that atom is electrically neutral particle. Now the second term that we were learning, and it is atomic mass. It is denoted by letter A. Atomic mass is denoted by letter A. So what is atomic mass, or what atomic mass is? It is also known as nucleon number. As I had already explained to you, it is also known as nucleon number. So what atomic mass is? Actually, atomic mass, it is the sum of protons and neutrons present in the nucleus. So atomic mass is the sum of protons and neutrons present in the nucleus, and we also call it mass number. It is also termed as mass number. We can also use this term to call it. Why we call it mass number? Because the mass of an atom depends on the number of protons and neutrons in the atoms of nucleus, and mass of electrons in the atom is said to be negligible. It is negligible as we had already discussed previously. So atomic mass which is A equals to number of protons plus number of neutrons. This is the expression that we use for the calculation of atomic mass. From the above expression, we can write it the number of neutrons in an atom. So number of neutrons means atomic mass. If we will shift number of protons over here, it will be subtracted from number of protons, it will be subtracted from atomic mass, and we will get number of neutrons. As we know that atomic mass is denoted by A, number of protons or proton number or atomic number is denoted by Z, and we can get number of neutrons. By considering the symbol of carbon atom again, it is 6 into 12. We know that this is atomic number Z and this is our atomic mass A. So by using this information, we are calculating number of neutrons of carbon atom, and it is A minus Z means 12 minus 6, answer will be 6. Similarly, if we have another symbol of element sodium, that is 11, its atomic number, and its atomic mass is 23. So number of neutrons of sodium atom, they can be written A minus Z, and it is 23 minus 11, answer will be 12. In this way, we can calculate the number of neutrons present in a nucleus of an atom, and we can also calculate the number of protons and electrons, because you know that we have the same number of protons and same number of electrons. For example, over here you can get the example protons from this are 11. As we have the same number of protons and same number of electrons in an atom, so electrons will also be 11. And we have calculated the neutrons over here in the atom of sodium, and neutrons are atomic mass minus atomic number to get the neutrons, which are 12. So this is about uh, the atomic structure, subatomic particles, atomic number and nucleon number. Hope you get this concept clearly.